Okie doke. Fifth video on Solo's mechanisms, and we're still on resource efficiency in the production function. And we've kind of said that, look, we're going to go with a CES and we're going to go with poor substitutability between the inputs. But now we are actually going to start getting into some of the math. So what have we got? Ideally, we would build our aggregate model from micro foundations of individual firms investing in resource efficiency to save on their input costs. And these firm level knowledge stocks then combining to form a general stock of knowledge about resource efficiency. And how this can be done is outlined in the paper I mentioned before from 2013 and lots of other places in the literature actually. But we skip this step and we go straight to the aggregate level, and we take the key result from the 2013 paper that aggregate investment in any given input actually is in proportion to the factor share of that input. So in our model we've got two inputs, labor and the resource, and aggregate investment in the resource compared to aggregate investment in labor is just in proportion to the factor share of the resource what firms spend buying resource inputs divided by what firms spend buying or hiring labor. Okay, so if you spend twice as much on resources than you do on labor, you're going to invest twice as much in trying to economize on resources by boosting AR, for instance. Okay, so this is super logical, and there is a full macro model behind this, but it's just a bit too tricky for this course. So we're just going to go straight to this result. Okay. But we still want to have a clear picture of the model, even if we're not going to work through it. Okay. So what have we got? We've got the knowledge sector and investment of research labor. We've got the final goods sector and production labor. And then we've got production, consumption, intermediate inputs into the energy sector, which I'll just draw like this, or the resource sector, and we've got the resource input. Okay, and I'll put a dotted line here because this isn't really a flow of inputs, it's just the stock of knowledge, well, whatever. The stock of knowledge here, or the levels of productivity will determine, or a part of the production function here. And remember, the production function, let's see if we've got this on the slide. No, we don't. Well, yeah, okay. The production function is this. It's CES ALL to the epsilon plus ARR to the epsilon to the 1 over epsilon. Okay, so what are we going to do? Let me just pause and think about what to say next. Right, yeah, I got it. So we've got that relative investments are given by the relative factor shares, and we've got this production function, but we don't know these factor shares. So how do we work those out? We need to set up the profit maximization function of this guy, right? The representative competitive final good producer. And this person's, that representative producer's profits are PY, Y, but PY we can normalize to 1, so we can just write Y. I should write this whole thing out, but I'm just going to write Y minus, so that's revenue minus costs, which is WLL WR. Okay. And then we say first order conditions d pi dl. So there's a fixed total labor, but each small producer can choose how much labor to hire, taking the wage as exogenous, right? So we've got perfect markets, loads of these producers, but we're focusing on the representative producer. So then we can write it this way, and we can say the representative producer takes WL and WR as given and chooses how much labor to hire and how much resource to buy. So d pi dl, we know at the optimum must be 0. And that is dy dl. So now, what is dy dl? I don't know, I can't remember if I went through this differentiating the CES before. But we have, this is chain rule, yeah? We've gone through the chain rule for sure. So this is 1 over epsilon times whatever was in those square brackets to the 1 over epsilon minus 1. Okay? And then we go inside, and then it's epsilon times this sorry, it's epsilon. If we're going to do this like an economist now, it's epsilon times ALL to the epsilon divided by L. Because this is like AL to the epsilon, L to the epsilon. So if we focus on the L to the epsilon, it's epsilon times ALL to the epsilon over L. Okay? But these two go out, and then we have this 1 over epsilon minus 1 is the same as 1 minus epsilon over epsilon. And then we've got ALL to the epsilon over L. But that square bracket thing to the 1 minus epsilon over epsilon is y to the 1 minus epsilon. So we end up with y to the 1 minus epsilon ALL to the epsilon over L minus WL. Remember, we're differentiating with respect to L. So that tells us that y to the 1 minus epsilon ALL to the epsilon is WLL, what we spend on labor. And there's a lot of symmetry here, so by symmetry we can say straight away that y to the 1 minus epsilon ARR to the epsilon is WRR, and therefore WRR over WLL is this over this. The y's go out, and we end up with ARR over ALL all to the epsilon. Okay, so when we have a perfect market with inputs R and L and this kind of CES production function formulated like this, the factor shares relative to one another are just given by this. And remember, epsilon is less than 1, they're not very good substitutes. So this is telling us that if we have little of an input, its share goes up, because this is negative. Yeah? So if an input is in short supply, we spend more on buying it, because we're buying less of it, but the price goes up by more than that, so to speak. to more than compensate because they're poor substitutes. So the quantity goes down a bit, the price goes up a lot, our spending on that input goes up when epsilon is negative. Okay, so now we can build on this and we can say the relative investments are WRR over WLL, which is equal to ARR over ALL to the epsilon. So far, so good. Okay. Now, if L and R are exogenous, and we know we've got some incoming, we've got some given levels for AR and AL, this will tell us, so this is then known, and this will then tell us, okay, therefore we know the relative investments going into the next period. This is what we're going to invest. Out of our investment input Z, we're going to put ZR into boosting AR, and we'll put ZL into boosting AL, and the ratio will be given by this. But what if it's actually not the quantities that are exogenously given? What if it's the prices? Okay, how do we deal with that? And I'm just going to pause to think about how to explain this. Right, so we want it to be, we want to get rid of R and L, and we want WR and WL instead. So we need to look at this, and we want to rearrange this to get R over L in terms of these and these. So we can split things up, and we can say R over L equals AR over AL to the epsilon, R over L to the epsilon, forget that, and then we've got WR over WL to the minus 1. Okay, we've shifted that across. Now we shift this across, and we have R over L to the 1 minus epsilon is AR over AL to the epsilon WR over WL to the minus 1. Okay, I'm just going to pause this again. Okay, so we got this. So then, sorry, I'm going off in the wrong direction here. Never mind. So then we've got R over L equals, raise everything to the power 1 over 1 minus epsilon, AR over AL to the epsilon over 1 minus epsilon, WR over WL to the minus 1 over 1 minus epsilon. So that's R over L. Now we want to stick that in here. Yeah, because actually what we really want is ARR over ALL. Okay, so if we multiply this by AR over AL, I'm probably doing this, I'm sure you could do this an easier way. Sorry, never mind. We multiply by AR over AL. So then we need to add AR over AL to the epsilon over 1 minus epsilon plus 1, which is plus 1 minus epsilon over 1 minus epsilon. So we've got epsilon plus 1 minus epsilon over 1 minus epsilon. So that's 1 over 1 minus epsilon. So ARR over ALL is actually AR over AL to the 1 over 1 minus epsilon, WR over WL to the minus 1 over 1 minus epsilon. ARR over ALL to the epsilon is AR over AL to the epsilon over 1 minus epsilon, WR over WL to the minus epsilon. which finally, I'm sure we could have done this an easier way. I mean, it's basically the same principle, but I think I've made it unnecessarily complicated here. But never mind, we end up with AR over WR divided by AL over WL, all to the epsilon over 1 minus epsilon. So this is what we use if the quantities are exogenously given. This is what we use if the relative prices are exogenously given. So if the price of the resource is some fraction of the cost of labor, then we need to use this. Okay. And again, here we see epsilon over 1 minus epsilon is negative. So if WR, the price of the resource, goes up compared to the price of labor, this inside goes down, this is negative, so this whole thing goes up, the whole thing. So if WR goes up, this goes up, the resource share goes up, resource investment goes up. When the price of the resource goes up, we spend more buying resource inputs, we invest more in resource efficiency. Okay, let's see if we've got another slide, or hopefully, yeah, long video this one. What then? So that's how the sort of initial state of the system feeds through into the factor share and feeds through into investments into resource efficiency. But how do these investments affect the next period efficiency levels, AR and AL, in the coming period? Okay, what's the dynamics of the model? That is what we'll go through in the next video.